If you build a card castle using the pattern shown in the figure below, how many cards would be in the 30th row? Which is a row? Oh, okay, first row. I'm going to separate that out here. That's my first row. Second row. How many cards would be in the 30th row? Okay. How many cards are in the first row? We have 1, 2, 3. So 3 cards in the first row. How many cards in the second one? 1, 2, 3, 1, 2, 3, 6. Okay, so let's write down the pattern. So it's going to be 3, 6, and I think the next one's going to have 3 triangles, so it'll be 9. And I think it looks like an addition, but let's just check that. Let's check if it is an arithmetic series. So k for an arithmetic series is a to the n plus 1 minus a to the n. So let's check 9 minus 6 is equal to 3, and 6 minus 3 is equal to 3. So yes, indeed, it is an arithmetic sequence. Okay, so I know for the arithmetic sequence, a to the n is equal to a to the 1 plus n minus 1 times k. I know k. N, it asks me for the 30th row. And A1, well, A1 is right here because that is the first row. That are 3. Okay, so let's just put all that in. So a to the 30 is equal to 3 plus n 30 minus 1 times k, which is 3. So a to the 30 is equal to 30. 29 times 3 equals plus 3 is 90. Okay, 90 cards will be in the 30th row. Might ask us a sum. Let's see what it's ask us. How many rows could you build out of 381 card decks? How many cards? Oh, how many cards are in a deck? I think it was 64. So 381 times 64 is 24,384 cards. How many rows? Whew, okay, so this is the total number of cards used. So this is equal to Sn. That's the sum. We usually solve for that. But now I'm solving for n. Let's write down the equation for sum, because it gives us the sum. Here's the we build out of this many card. Yeah, so this is how many cards are in the thing. So for an arithmetic sequence, the sum is equal to n a1 plus an all over 2. Okay, so I know Sn. N, what's n? N is the number of rows. Right. Yeah, 30 here. So that's what I'm trying to solve for. How many rows could you put? Oh, I'm trying to solve for n. I'm trying to find n here. A1 I know. So I know A1 and I know Sn. That's A1. An. Well, I need to know how many cards are in the three. I don't know the row. Oh, but I know the equation. Okay, so let's substitute that in here. Okay, because I want to get rid of my an variable because I don't know two variables here. I don't know n or an. And over here in this equation, equation number 1, I don't know an, I know that one, I know n, I know k. So I have two unknowns here. I have an unknown and n unknown. So I have two equations, two unknowns. Let's substitute 1 into 2. Here comes an. So I just took the 2 out there, I put in a front coefficient, a1, and now we're going to substitute an. So it's going to be a1. Okay, now we're going to expand everything. Actually, I'm just going to multiply everything by 2 to get rid of that 2, and then I'm going to expand the brackets. Actually, I'll probably just expand this bracket first because I can just drop them right away. So let's multiply everything by 2. So I'm going to get 2 Sn is equal to n. We open a. I have 2. Oh, 2's gone from there. But I do have two A1s. A1, I'll just write down A1. So I'll expand this guy. Nk minus k. Okay, and one more time. 2Sn is equal to 2A1n, because those two come together, plus kn squared minus kn. Okay, this looks like a quadratic equation. Let's put it in quadratic equation form. 0 equals kn squared plus bracket open 2a1 minus k times n minus 2sn. That is a quadratic equation because I know k, so that'll be a number. I know a1 and I know k, so that'll be a number. And I know 2sn. So all I don't know is n's. Right? We knew that, right? We didn't know an and we didn't know n. That's why we did a substitution to get rid of our an. So all we didn't know is n. We can't solve for it directly just because it is a quadratic equation. We have a squared and a single in there. So we need to use a quadratic equation. So let's substitute some numbers in now. So 0 equals k. What was k? K was determined to be 3 n squared plus 2a1, so a1, 2 times a1, which is 3, minus k is 3. So I need to write the bracket there, but I'll write the bracket. 3n minus 2sn, oh, 24,384 times 2, 48,768. Okay. Minus b plus or minus square root b squared minus 4ac all over 2a. Okay, let's put some numbers in here. So I get minus 3 plus or minus square root 3 squared, which is 9, minus 4 times a times c. Okay, it's a big number. And I have a negative here because a is positive, but c is negative, so it's going to be a plus. Plus 4 times 3 times 48768 is going to be 585216 all over 2a, which is 6. Okay, so n is equal to, now, so it's going to be minus 3 over 6, which is 1/2, plus or minus that number plus 9, square root answer, and then divide it by 6. So it's 100 plus or minus 127.5. Okay, so our two answers from that would be negative 0.5 minus, or no, plus this answer is going to be 127, or it would be negative 0.5 minus 127.5, and that's going to be negative 128. Okay, so the only one that makes sense is 127. Yes, this is a solution, but it doesn't make physical sense. We can't have a negative row. So it's going to be 127 rows. 127 rows will give me that many cards with that k difference.